Jupiter drifts through space at a great distance from our world, a gentle giant moving slowly along its path around the Sun. It is the largest planet in our solar system, a vast sphere of swirling gas and soft colors that has been turning quietly for billions of years. When we look up at the night sky and see Jupiter as a bright point of light, we are seeing something enormous, something far larger than our own planet, yet moving with a slow and patient grace through the darkness of space. The planet is made mostly of hydrogen and helium, the same light gases that make up the Sun, though Jupiter never became hot enough to ignite and become a star itself. Instead, it exists as something in between, a world of gas and cloud that has no solid surface to stand upon. If you could somehow descend into Jupiter's atmosphere, you would pass through layer after layer of cloud, each one slightly different in color and composition, drifting deeper and deeper until the gas becomes so dense and the pressure so great that the hydrogen itself begins to behave like a liquid metal, far below where any light can reach. The clouds of Jupiter move in bands that wrap around the planet, alternating stripes of cream and tan and soft orange, with touches of rust and pale brown. These bands are created by winds that blow steadily in opposite directions, some moving east and others moving west, creating boundaries where the different flows meet. The lighter bands are called zones, and they are regions where gas is rising up from below, cooling as it reaches higher altitudes. The darker bands are called belts, and they are places where gas is sinking back down, completing a slow circulation that has continued for as long as Jupiter has existed. The winds on Jupiter blow at speeds that would seem fast to us, yet when you consider the enormous size of the planet, these winds are simply another part of its slow and steady nature. They move the clouds along, creating swirls and eddies, small storms and large ones, all drifting across the face of the planet in patterns that change gradually over time. The planet rotates quickly for something so large, spinning once every 10 hours or so, which helps to stretch the clouds into those long horizontal bands. This rotation is faster than Earth's, yet the motion feels gentle when you think of the vast distances involved, the whole enormous sphere turning smoothly in the darkness. One of the most well-known features on Jupiter is a large storm called the Great Red Spot. This storm has been observed for hundreds of years, a swirling oval of reddish-brown cloud that drifts slowly across the planet's southern hemisphere. The storm is larger than our entire Earth, yet it appears as just one feature among many on Jupiter's vast face. The Great Red Spot rotates slowly, its winds circling in a counterclockwise direction, creating a stable pattern that has persisted for centuries. The exact reason for its color is not entirely understood, but it may come from chemicals in the atmosphere that change when exposed to sunlight, creating that distinctive rust-colored hue. The storm drifts along with the cloud bands, moving slowly westward as the years pass. It has been shrinking gradually over the past century, though it remains enormous by any measure. The winds within the storm blow steadily, and the whole structure turns with a quiet persistence, a long-lasting weather pattern on a world where there are no seasons, no land, and no oceans, only layer upon layer of gas and cloud stretching down into the depths. Jupiter is so large that more than 1,000 Earths could fit inside it. If you could line up planets side by side, it would take 11 Earths to stretch across Jupiter's diameter. Yet despite this enormous size, Jupiter is not a heavy planet in the way we might expect. Because it is made of light gases, it is actually less dense than water. If there were an ocean large enough to hold it, Jupiter would float, though of course no such ocean exists. This lightness, combined with its great size, gives Jupiter a unique character among the planets, a world of vast dimensions but gentle substance. The gravity on Jupiter is stronger than on Earth, a natural consequence of its great mass. If you could somehow stand on a solid surface deep within Jupiter's atmosphere, you would feel yourself pulled down with more than twice the force you experience on Earth. Yet at the cloud tops, where spacecraft have passed by and taken their measurements, the gravity is simply another aspect of the planet's presence, a gentle pull that holds the thick atmosphere in place and keeps all those clouds circling endlessly around the planet's center. Beyond the clouds, beyond the visible surface, Jupiter's atmosphere grows denser and warmer. The pressure increases slowly as you move inward, and the temperature rises. Eventually, the hydrogen gas becomes so compressed that it starts to behave like a liquid, and deeper still, it may take on properties of a metal, conducting electricity in strange and quiet ways. At the very center of Jupiter, there may be a core of heavier elements, rock and ice compressed under unimaginable pressure, though this remains hidden from direct observation, a secret kept within the planet's heart. Jupiter has a magnetic field, much stronger than Earth's, generated by the movement of that metallic hydrogen deep inside. This magnetic field extends far out into space, creating an invisible bubble around the planet that traps charged particles and deflects the solar wind. The field is tilted slightly compared to Jupiter's axis of rotation, and it sweeps around as the planet turns, creating gentle variations in the space environment around the giant world. If you're still awake, that's perfectly fine. Let your thoughts drift along with these clouds, moving slowly across the face of this distant planet. Jupiter has many moons, more than any other planet we know of in our solar system. These moons come in many sizes, from tiny irregular rocks just a few miles across to worlds that are larger than some of the planets. The 4 largest moons were discovered long ago by Galileo when he first pointed a telescope at Jupiter, and they have been watched ever since, circling the planet in their slow and predictable paths. These 4 moons are called the Galilean moons, and each one is different from the others, each with its own quiet character. Io is the innermost of the large moons, and it orbits close to Jupiter, completing a circuit in just over a day and a half. Io is a world of volcanoes, the most volcanically active body in the solar system, though even this activity happens in a slow and steady way when viewed across the vastness of space. The volcanism on Io is driven by the gravitational pull of Jupiter and the other large moons, which flex and squeeze Io's interior, generating heat. This heat rises to the surface, and volcanoes erupt quietly, sending plumes of sulfur and other materials high above the moon's surface before they fall back down, covering the landscape in layers of yellow and orange and white. Europa orbits farther out, taking about 3.5 days to circle Jupiter. Europa is covered in ice, a smooth frozen crust that wraps around the entire moon. The ice is crisscrossed with long lines and cracks, patterns that suggest the surface moves and shifts over time. Beneath this icy shell, there may be an ocean of liquid water, kept warm by the same kind of tidal heating that affects Io, though to a lesser degree. This ocean, if it exists, would be hidden under miles of ice, a dark and quiet sea that has never seen sunlight, yet might harbor its own form of life, something simple and slow, adapted to the cold and the darkness. Ganymede is the largest moon in the solar system, bigger even than the planet Mercury, though with less mass. Ganymede has its own magnetic field, the only moon known to have one, generated by a liquid iron core deep within. The surface of Ganymede is a mixture of old dark terrain and younger lighter areas, regions that have been shaped by impacts and by internal processes over billions of years. Ganymede also has a thin atmosphere, made mostly of oxygen, though so thin it would be considered a vacuum by our standards. The Moon orbits Jupiter once every 7 days or so, moving steadily along its path while the planet slowly turns beneath it. Callisto is the outermost of the 4 large moons, orbiting at a greater distance from Jupiter and taking about 16.5 days to complete one circuit. Callisto is heavily cratered, its surface marked by countless impacts that have accumulated over the age of the solar system. The Moon appears to have changed little since its formation, preserving a record of the ancient bombardment that all the planets and moons experienced long ago. Callisto's surface is a mix of ice and rock, dark and quiet, a world that has settled into a stable state and remained there for billions of years. As we drift onward through this quiet contemplation, we can think about the other smaller moons that circle Jupiter, dozens of them discovered over the years as telescopes and spacecraft have improved. Some of these moons orbit close to the planet, while others travel in wide elliptical paths far from Jupiter's warmth. Some move in the same direction as Jupiter's rotation, while others orbit backward, suggesting they were captured by Jupiter's gravity long ago, small asteroids that wandered too close and became permanent companions of the giant planet. Jupiter has a ring system, though it is much fainter than Saturn's famous rings. The rings of Jupiter are made of small dark particles, likely dust knocked off the inner moons by tiny impacts. These particles orbit the planet in a thin disk, too faint to be seen easily from Earth but visible when spacecraft pass close by and look back toward the Sun, seeing the dust illuminated in the scattered light. The rings are delicate and temporary on cosmic timescales, constantly being replenished by new dust while old particles slowly spiral inward toward the planet or are swept away by Jupiter's magnetic field. The presence of Jupiter in our solar system has influenced the other planets in subtle ways. Its strong gravity affects the orbits of asteroids, sometimes sending them on new paths, and it may have played a role in shaping the early solar system, helping to determine where the planets formed and how they evolved. Some scientists think that Jupiter acts as a shield for the inner solar system, its gravity attracting comets and asteroids that might otherwise travel inward toward Earth and the other rocky planets. When a large comet or asteroid passes through the outer solar system, there is a chance it will be captured by Jupiter or deflected onto a different path, reducing the number of impacts on the inner worlds. Slowly, over the years, spacecraft have visited Jupiter, passing by or orbiting for extended periods, sending back images and data that have helped us understand this distant world. The first spacecraft to reach Jupiter were simple probes that flew past quickly, taking pictures and measurements before continuing on into the outer solar system or falling silent. Later missions orbited Jupiter for years, studying the planet, its moons, and its magnetic environment in detail. One spacecraft even sent a small probe down into Jupiter's atmosphere, measuring the temperature, pressure, and composition as it descended through the clouds before being crushed by the increasing pressure far below. These missions have shown us Jupiter's clouds in exquisite detail, revealing the intricate patterns and colors, the small storms and the large ones, the way the bands shift and change over months and years. They have shown us the surfaces of the moons, the volcanoes on Io erupting silently in the vacuum of space, the fractured ice of Europa reflecting the faint sunlight. The spacecraft have measured Jupiter's magnetic field and discovered the intense radiation belts that surround the planet, regions of space filled with high-energy particles trapped by the magnetic field and circling endlessly around Jupiter. Another quiet detail is the way Jupiter reflects sunlight. The planet is far from the Sun, receiving much less light than Earth does, yet it is bright in our sky because of its great size. The clouds reflect a significant portion of the sunlight that reaches them, sending it back out into space. This reflected light is what we see when we look at Jupiter through a telescope or with our eyes alone. The planet shines with a steady, cream-colored glow, a gentle beacon in the night sky that has been watched by humans for thousands of years. Jupiter completes one orbit around the Sun every 12 years or so, moving slowly through the background of stars. Ancient observers noticed this motion and tracked Jupiter's position carefully, using it to help measure time and mark the passage of years. The planet's slow progress across the sky gave it a sense of permanence and stability, a wandering star that returned to the same constellations in a predictable cycle. Even today, Jupiter remains one of the brightest objects in the night sky, easy to find and pleasant to observe, a reminder of the larger universe that surrounds us. As we drift onward, we can think about the energy within Jupiter. The planet radiates more heat than it receives from the Sun, a gentle warmth that comes from its interior. This heat is left over from Jupiter's formation, when gas and dust came together under gravity and compressed, generating warmth that has been slowly leaking out ever since. The planet is still contracting very gradually, shrinking by tiny amounts each year, and this contraction generates a small amount of additional heat. This internal warmth drives some of the atmospheric circulation, adding to the energy provided by the Sun and helping to create the complex weather patterns we see in the clouds. The seasons on Jupiter are barely noticeable because the planet's axis is tilted only slightly compared to its orbit. This means that each hemisphere receives roughly the same amount of sunlight year-round, and there are no dramatic seasonal changes like we experience on Earth. The clouds continue their steady circulation, the storms persist or evolve slowly, and the overall appearance of the planet remains much the same throughout its long year. This constancy is part of Jupiter's character, a world of slow and predictable rhythms that has maintained its nature for billions of years. If you're still awake, that's perfectly fine. Let these thoughts about Jupiter carry you gently along, a slow drift through information that asks nothing of you, just offering quiet details to occupy your mind as you rest. Jupiter's great red spot has been shrinking gradually over the past century or more. Observations from the 1800s show it was larger than it is now, though it remains enormous by any measure. The exact reason for this shrinking is not fully understood, but it may be related to changes in the winds that surround the storm or variations in the heat flow from below. Despite the shrinking, the storm continues to turn, a long-lived feature that may persist for many more years or may eventually fade away, joining the countless other storms that have formed and dissipated on Jupiter over the ages. The colors in Jupiter's clouds come from trace amounts of chemicals in the atmosphere. The bulk of the atmosphere is hydrogen and helium, colorless gases, but small amounts of ammonia, methane, water vapor, and other compounds create the soft tans and browns and reds we see. Some of these compounds change color when exposed to sunlight or when mixed with other chemicals, creating the varied palette of Jupiter's clouds. The exact composition and the processes that create the colors are still being studied, but the result is a world of gentle hues, a subtle beauty that appears different each time we look closely. Another moon worth mentioning is Amalthea, a small irregular moon that orbits close to Jupiter, inside the orbit of Io. Amalthea is shaped like a potato, with a long axis and two shorter ones, and it is covered in dark reddish material, possibly from sulfur that escaped from Io and eventually settled on Amalthea's surface. This little moon is heavily cratered, marked by impacts from small pieces of rock and ice that have struck it over the years. It orbits Jupiter quickly, completing a circuit in less than half an Earth day, rushing through the radiation belts that surround the planet. Jupiter's rotation creates a slight bulge at its equator. The planet is not a perfect sphere but is slightly flattened at the poles and wider at the middle, a consequence of the rapid spin. This bulge is subtle, but measurable, and it affects the way the planet's gravity pulls on its moons and on passing spacecraft. The shape of Jupiter, combined with its mass and rotation, creates a gravitational field that is complex in detail but gentle in its overall influence, guiding the moons in their orbits and shaping the structure of the surrounding space. The temperature at the cloud tops of Jupiter is very cold, well below freezing by our standards, around -200 degrees Fahrenheit or so. This cold is expected at such a great distance from the Sun, where sunlight is weak and provides little warmth. Yet as you move deeper into the atmosphere, the temperature rises steadily, increasing with depth until eventually it becomes warm, then hot, then extremely hot as you approach the core. This gradual increase in temperature is part of what drives the circulation in Jupiter's atmosphere, warm gas rising and cool gas sinking, creating the bands and zones we see from the outside. Slowly, the study of Jupiter continues. New spacecraft are planned or are already on their way, carrying instruments to measure the magnetic field, study the moons, analyze the atmosphere, and search for clues about how the planet formed and how it has evolved. Each mission adds a little more to our understanding, filling in details and answering questions while raising new ones. The process is slow and careful, built on observations and measurements, theory and modeling, a gradual accumulation of knowledge about this distant world. Jupiter's influence on the solar system extends beyond its immediate surroundings. The planet's gravity affects the orbits of comets in the outer solar system, and it has been known to capture comets temporarily, causing them to orbit Jupiter for a while before they escape again or crash into the planet. In the past, impacts have been observed, dark marks appearing in Jupiter's clouds where fragments of a broken comet struck the atmosphere, creating temporary scars that eventually faded as the clouds circulated and the material dispersed. These events are rare but remind us that Jupiter is not isolated, but part of a dynamic system where objects occasionally interact in dramatic ways, though even these dramas unfold over days and weeks, not in sudden moments. Another quiet detail is the way Jupiter's moons interact with each other through gravity. The orbits of Io, Europa, and Ganymede are linked in a pattern called orbital resonance, where Io completes 4 orbits for every 2 of Europa and every 1 of Ganymede. This precise relationship keeps the Moon's orbit slightly elliptical rather than circular, which increases the tidal forces they experience from Jupiter and contributes to the internal heating that drives the volcanism on Io and may maintain the ocean beneath Europa's ice. This resonance is stable and has likely persisted for billions of years, a quiet dance of 3 moons moving together in a coordinated pattern. The faint rings of Jupiter were discovered not from Earth but by a passing spacecraft, which looked back at the planet with the Sun behind it, seeing the rings glowing faintly in the scattered light. Before this discovery, it was not known that Jupiter had rings at all, because they are so thin and dark that they are invisible from Earth even with powerful telescopes. The discovery added another detail to our picture of Jupiter, another layer of complexity in the structure of the planet and its surroundings. If you're still awake, that's perfectly fine. These quiet facts about Jupiter are here simply to accompany you, to give your mind something gentle to consider as you rest, asking nothing more than your passive attention as the words flow slowly past. Jupiter has been a subject of study and wonder for as long as humans have looked up at the sky. Ancient civilizations noticed it moving among the stars and gave it names, associating it with gods and myths. The Romans called it Jupiter, after their king of the gods, a fitting name for the largest planet in the sky. Other cultures had their own names and stories, but all recognized the planet's brightness and slow, steady motion across the heavens. When telescopes were invented, Jupiter was one of the first objects observers turned toward, eager to see what details might be revealed. They saw the planet as a disk rather than a point of light, and they noticed bands of light and dark across its face. They discovered the 4 large moons, tiny points of light that moved from night to night, sometimes disappearing behind the planet or in front of it, providing clear evidence that not everything in the universe circles the Earth. These early observations helped to change our understanding of the cosmos, showing that other worlds exist, some with their own satellites, all moving according to the same laws of gravity and motion. The study of Jupiter from Earth continued for centuries, with observers noting changes in the bands, tracking the Great Red Spot, and measuring the planet's rotation rate. They discovered additional small moons and measured the planet's size and mass with increasing precision. Each generation of astronomers added a little more to the picture, building on the work of those who came before, slowly piecing together an understanding of what Jupiter is and how it behaves. When spacecraft finally reached Jupiter, they confirmed much of what had been learned from Earth but also revealed new details that could not be seen from so far away. They showed the complexity of the cloud patterns, the variety of storms and eddies, the structure of the magnetic field, and the harsh radiation environment. They photographed the moons up close, revealing their surfaces in detail for the first time. These missions transformed Jupiter from a distant bright light in the sky to a real place, a world with specific features and characteristics, a planet that could be studied and understood in much greater depth. Another gentle detail is that Jupiter's day is only about 10 hours long, meaning the entire planet rotates once in that short time. This rapid rotation, combined with the planet's great size, means that a point on Jupiter's equator is moving through space at tremendous speed, racing around the axis as the planet spins. Yet when we observe Jupiter, this rotation appears smooth and steady, the whole planet turning with a quiet grace that belies the speed of the motion. Jupiter's atmosphere is layered, with different altitudes having different temperatures and compositions. The cloud tops we see are made primarily of ammonia ice crystals, frozen particles suspended in the hydrogen and helium gas. Below this, there may be clouds of ammonium hydrosulfide, and deeper still, clouds of water ice and water droplets, though these lower clouds are hidden from view by the upper layers. Each layer contributes to the overall appearance of the planet, creating the bands and zones and the subtle variations in color that make Jupiter so visually interesting. The winds in Jupiter's atmosphere are driven by several factors, including the heat from the Sun, the internal heat from the planet itself, and the rapid rotation. These factors combine to create a circulation pattern that organizes itself into the bands we see, with winds blowing in alternating directions at different latitudes. The exact mechanisms that maintain these patterns are still being studied, but the overall structure has remained stable for as long as we have been able to observe it, suggesting that whatever processes are at work are long-lived and self-sustaining. Slowly, as we drift onward, we can think about the way Jupiter would appear if we could see it up close, not from Earth but from a spacecraft passing nearby. The planet would fill the sky, a vast curved expanse of swirling clouds stretching from horizon to horizon. The bands would be clearly visible, each one a river of wind and cloud moving at its own pace. The great red spot would stand out, a giant oval of rust-colored cloud turning slowly in the southern hemisphere. Smaller storms would dot the face of the planet, white ovals and brown patches, eddies and swirls, all part of the ever-changing yet somehow constant weather of Jupiter. The moons would be visible too, small worlds orbiting the giant planet, some showing a disk rather than a point of light, revealing their surfaces. Io would appear yellow and orange, marked by volcanic features. Europa would be smooth and white, its icy surface reflecting sunlight brightly. Ganymede would show its patchwork of dark and light terrain, and Callisto would appear darker, heavily marked by ancient craters. These moons, along with dozens of smaller ones, make Jupiter not just a planet but a miniature solar system, a complex and interconnected collection of worlds bound together by gravity. Jupiter's magnetic field creates auroras near the planet's poles, similar to the northern and southern lights on Earth but on a much larger scale. These auroras are caused by charged particles from the solar wind and from volcanic emissions from Io, which follow the magnetic field lines down into Jupiter's atmosphere near the poles. The particles collide with atoms and molecules in the upper atmosphere, causing them to glow. The auroras on Jupiter are bright and persistent, a constant feature of the polar regions, visible in ultraviolet and infrared light though not in the visible spectrum. Another quiet detail is that Jupiter emits radio waves, crackling bursts of energy that can sometimes be detected by radio telescopes on Earth. These emissions are created by processes in Jupiter's magnetosphere, where charged particles spiral along magnetic field lines and emit radiation. The radio bursts are irregular and unpredictable, a kind of natural radio signal from the giant planet, though they carry no message, only the random noise of natural processes. If you're still awake, that's perfectly fine. Let your thoughts continue to drift along with these details, floating gently through facts about Jupiter, a world far away, turning slowly in the darkness, a quiet presence in the solar system. The distance from the Sun to Jupiter is enormous, about 5 times the distance from the Sun to Earth, or roughly 480 million miles. Light from the Sun takes over 40 minutes to travel this distance, meaning that the sunlight illuminating Jupiter's clouds left the Sun nearly an hour before it arrived. This vast distance means that Jupiter receives only a small fraction of the sunlight that Earth does, and the planet is correspondingly cold, though not as cold as the more distant outer planets. Jupiter's year is long, 12 Earth years, meaning it takes that long for the planet to complete one orbit around the Sun. During this time, the planet moves steadily along its path, a great slow arc through space that brings it through different parts of the sky as seen from Earth. The orbit is slightly elliptical, meaning the distance between Jupiter and the Sun varies a little over the course of the year, though this variation is small and does not create significant differences in the planet's temperature or appearance. The study of Jupiter's interior is challenging because we cannot see below the cloud tops, and no probe has ever survived long enough to reach the deep layers. Instead, scientists use indirect methods, measuring the planet's gravitational field, its magnetic field, and the way it responds to tidal forces from the Sun and moons. These measurements, combined with computer models, allow them to infer what the interior must be like, though many details remain uncertain. The models suggest a gradual transition from gas to liquid to metallic hydrogen, with possibly a core of heavier elements at the center, but the exact structure and composition are still subjects of research. Another gentle detail is that Jupiter is often visible in the night sky without a telescope, appearing as a bright, steady light that does not twinkle like stars do. This steadiness comes from the fact that Jupiter is a planet, a disk of light rather than a point, and the different parts of the disk average out the effects of Earth's atmospheric turbulence. The brightness of Jupiter makes it easy to find, and it has been a guide for navigators and a subject of interest for skywatchers for thousands of years. The moons of Jupiter have been studied in detail, and each one has revealed its own unique characteristics. Some of the smaller moons are irregularly shaped, fragments of larger bodies that were broken apart by collisions long ago. Others are thought to be captured asteroids, rocks that once orbited the Sun independently but were pulled in by Jupiter's gravity and now circle the planet in distant, elongated orbits. These small moons are dark and rocky, bearing the scars of countless impacts, quiet witnesses to the violent history of the early solar system. Slowly, the narrative of Jupiter unfolds, a story of a giant world that has remained largely unchanged for billions of years, a stable presence in the solar system. Its gravity has shaped the orbits of other bodies, its moons have evolved in different ways, and its atmosphere has continued to circulate in the same patterns year after year. The planet is a reminder of the scale and age of the universe, a world that existed long before Earth formed life, and that will continue long after the Sun has changed and the inner planets have been transformed. As we drift onward, we can think about the role Jupiter plays in our understanding of planets in general. Because it is a gas giant, very different from the rocky planets like Earth, Jupiter helps us understand the diversity of worlds that can exist. It shows us that planets can be made almost entirely of gas, that they can have powerful magnetic fields, that they can host many moons and even faint rings. The study of Jupiter informs our search for planets around other stars, giving us examples of the kinds of worlds that might exist elsewhere in the galaxy. Jupiter's presence in the solar system also raises questions about how planets form. The planet contains such a large amount of hydrogen and helium that it must have formed early, before the solar wind from the young sun blew away the gas from the inner solar system. Jupiter likely formed from a core of rock and ice that grew large enough to attract and hold onto the surrounding gas, building up mass until it reached its current size. The details of this process are still being worked out, but Jupiter serves as a key example of how giant planets can come into being. Another quiet detail is that Jupiter has been used as a gravity assist for spacecraft traveling to the outer solar system. When a spacecraft passes close to Jupiter, it can use the planet's gravity to change its speed and direction, gaining energy for the journey ahead without using fuel. This technique has allowed missions to reach distant targets like Saturn, Uranus, Neptune, and even to leave the solar system entirely, using Jupiter as a stepping stone on their long voyages. Each time a spacecraft performs this maneuver, it demonstrates the practical value of understanding the gravitational dynamics of the planets, turning knowledge into capability. If you're still awake, that's perfectly fine. These facts about Jupiter are simply here, flowing past like the clouds on the planet itself, asking nothing of you, just offering gentle information to accompany you as you rest. The great red spot on Jupiter is sometimes accompanied by smaller white ovals and brown barges, smaller storms that drift along nearby. These features interact with the great red spot in complex ways, sometimes merging with it, sometimes being deflected around it, creating a dynamic region of the atmosphere that is constantly changing in detail while remaining stable in overall structure. The interactions between these storms are driven by the same winds and circulation patterns that organize the whole atmosphere, and they provide a window into the processes that govern weather on giant planets. Jupiter's clouds are not static but are constantly being replenished and altered by convection from below. Warm gas rises from the interior, carrying heat and moisture upward, and when it reaches the colder upper layers, the moisture condenses into clouds. These clouds are then carried along by the winds, creating the bands and patterns we see. The process is similar in some ways to the formation of clouds on Earth, though the details are different because of the different composition and conditions on Jupiter. The magnetic field of Jupiter extends far out into space, forming a magnetosphere that is the largest structure in the solar system, even larger than the Sun itself. If we could see it, it would appear as a vast bubble surrounding the planet, shaped by the solar wind and by Jupiter's rotation. Inside this bubble, charged particles are trapped and accelerated to high energies, creating intense radiation belts that are hazardous to spacecraft. The magnetosphere is a complex and dynamic environment, constantly responding to changes in the solar wind and to the volcanic activity on Io, which adds material to the system. Another gentle detail is that Jupiter's atmosphere contains lightning, bolts of electricity that leap between clouds just as they do on Earth. These lightning strikes have been detected by spacecraft, which can see the flashes in visible light and also detect the radio bursts that accompany them. The lightning on Jupiter is similar in nature to lightning on Earth, caused by the buildup of electrical charge in clouds and the sudden discharge when the voltage becomes too great. The presence of lightning suggests that Jupiter's clouds have complex internal structures, with different regions carrying different charges, just as thunderclouds do on Earth. Jupiter's orbit around the Sun is influenced slightly by the gravitational pull of the other planets, particularly Saturn, the next giant planet outward. These influences are small but measurable, causing tiny variations in Jupiter's path that accumulate over time. Astronomers can use these variations to refine their understanding of the masses and orbits of the planets, creating ever more accurate models of the solar system's dynamics. The precision of these models is remarkable, allowing predictions of planetary positions years or even centuries into the future. Slowly, as the information continues to flow, we can think about the way Jupiter appears in photographs taken by spacecraft. The images show a world of subtle colors and intricate patterns, with details that are beautiful in their complexity. The swirls and eddies in the clouds, the long streaks where winds blow in straight lines, the round ovals of storms, all combine to create a picture that is both alien and somehow familiar, a reminder that the same physical laws govern weather everywhere, whether on Earth or on a giant planet far from the Sun. Jupiter's role in the solar system as a protector of the inner planets is sometimes overstated, but there is truth to the idea. The planet's strong gravity does deflect some comets and asteroids, changing their orbits and reducing the chance that they will strike Earth. However, Jupiter can also send objects inward, so the effect is complex. Overall, the presence of Jupiter has shaped the distribution of small bodies in the solar system, creating regions where asteroids are more common and others where they are rare, and influencing the long-term evolution of the system. Another quiet detail is that Jupiter has been observed by every generation of astronomers since the invention of the telescope. Each new generation has brought better instruments, allowing them to see more detail and make more precise measurements. The progression from simple telescopes to space-based observatories has revealed Jupiter in ever greater clarity, showing features that earlier observers could only imagine. Yet the fundamental nature of the planet has remained the same, a giant world of gas and cloud, turning steadily in the darkness, a constant presence in the night sky. If you're still awake, that's perfectly fine. Let these thoughts about Jupiter drift through your mind, gentle and undemanding, a slow stream of information that requires no effort to follow, just allowing the words to wash over you as you rest. Jupiter's temperature structure creates a stable layering in the atmosphere, with warmer gas below and cooler gas above. This stability means that vertical motion is limited, and most of the movement is horizontal, along the bands. The winds blow steadily within each band, carrying clouds and small storms along with them, creating the striped appearance that is so characteristic of Jupiter. The stability of this structure has allowed the bands to persist for centuries, a long-lived feature of a slowly changing world. The study of Jupiter continues to evolve as new techniques and instruments become available. Future missions may place more sophisticated probes into the atmosphere, measuring conditions at different depths and providing direct samples of the composition. Other missions may focus on the moons, exploring their surfaces and searching for signs of geological activity or even life. Each new mission builds on the knowledge gained from previous ones, gradually filling in the details of our understanding of this complex system. Jupiter's clouds occasionally show transient features, bright spots or dark marks that appear and then fade away over days or weeks. These features may be caused by storms rising from deeper in the atmosphere, or by changes in the chemical composition of the clouds. They add variety to the planet's appearance, ensuring that no two observations are exactly the same, though the overall pattern of bands and zones remains constant. Another gentle detail is that Jupiter has been the subject of much speculation and imagination over the years. Science fiction writers have set stories on Jupiter's moons, imagining bases and colonies, encounters with strange forms of life, and explorations of the giant planet's dangerous environment. These stories, while fictional, have helped to inspire interest in Jupiter and have encouraged the exploration of the real planet and its moons. The boundary between imagination and science is often blurred, with each informing the other, creating a rich tapestry of ideas and possibilities. The distance from Earth to Jupiter varies as both planets orbit the Sun. At their closest approach, called opposition, Jupiter can be about 390 million miles from Earth. At their farthest, when they are on opposite sides of the Sun, the distance is much greater, over 600 million miles. This variation means that the best time to observe Jupiter from Earth changes from year to year, though the planet is always bright enough to be easily visible when it is in the night sky. Jupiter's presence in our sky has influenced human culture in many ways. It has been used to mark time, to navigate, and to inspire awe and wonder. Different cultures have seen different meanings in its steady light, but all have recognized it as something special, a wandering star that moves with purpose through the fixed constellations. This cultural significance adds another layer to our relationship with Jupiter, beyond the scientific study, a connection that goes back thousands of years. As we drift onward, we can think about the fact that Jupiter is just one of many giant planets in the universe. Around other stars, thousands of exoplanets have been discovered, and many of them are similar to Jupiter in size and composition. These distant worlds orbit their own suns, some close and hot, others far and cold, each one a variation on the theme of a gas giant. The study of Jupiter helps us understand these distant planets, providing a nearby example that we can observe in detail, a template for interpreting what we see around other stars. Jupiter's moons continue to be a focus of scientific interest, particularly Europa with its possible subsurface ocean. Future missions are being planned to explore Europa in detail, to study the ice shell and try to determine if the ocean beneath is habitable. These missions will carry instruments to measure the ice thickness, to search for plumes of water vapor erupting from the surface, and to analyze the composition of any material that might be escaping from below. The possibility of finding life, even simple microbial life, makes Europa one of the most exciting destinations in the solar system. If you're still awake, that's perfectly fine. These quiet facts continue to flow, each one a small piece of information about Jupiter, the giant planet that drifts through space far from our world, a presence in the solar system that has been there since the beginning, turning slowly, circling the Sun, a world of clouds and storms and many moons, a place of quiet wonder. And so the description of Jupiter comes to a gentle close, not with a dramatic conclusion but simply by letting the information fade away, much like the light from Jupiter itself fades as dawn approaches and the stars disappear into the brightening sky. The planet continues its slow journey around the Sun, its moons continue their orbits, its clouds continue to swirl, all happening in the silence of space, far from our everyday concerns, a reminder of the vastness and age of the universe, a distant world that we can study and admire, a bright point of light in the night that has watched over Earth for billions of years and will continue to do so for billions more.